Hello everyone, I am Madhuri Thorat from IT department of AISSMS IOIT College. I am going to explain you DFA. DFA means deterministic finite automata. Finite automata are called deterministic finite automata if the machine is read an input string one symbol at a time. That is, DFA can only read a one symbol at a time. Suppose two symbols are present in a string as A and B, then it can read either A or B. And deterministic refers to the uniqueness of the computation, which means there is only one path in a specific input from the current state to the next state. DFA can't accept null transition and it contains multiple final states. Now I am going to explain you definition of DFA. That means the formal definition of DFA. DFA can be defined in 5 tuples in which there are 5 entries. So now we discuss one by one. First one is Q. Q is a set of state of DFA. At least you should have one or more state in the state. Summation. Summation means it is a set of input symbols, and these symbols we are going to use building a string. It can be a 0 or 1, small a to z or capital A to z. Q0 is the initial state. It is the entry point of DFA. In DFA there should be at least or at most one initial state. F is a final state. In DFA, those state can accept the valid string that can be a final state. So it can be a multiple final state. And last one is del. Del, it defines a transition function. Okay, it defines a mapping of Q cross summation tends to Q. It is saying that take one state from the Q and take one symbol from a summation, then you get output as a state. Actually it is transition function, which is either telling that where to go, means from one state to another state. Okay, now we see one example of DFA is draw a DFA that accept a language L over input alphabets summation 0 and 1, such that L is the set of all strings starting with 0. We solve this example as a step by step. So first step is to identify language. In this example, DFA can accept those strings which having a substring as 00. So the language can be L equal to 00, 000, 001, 0001 and so on. Now we move towards the second step, that is to construct DFA from that language. Okay. For the simplicity, we draw a finite automata for a smallest string, that is the 00. So in this finite automata, Q0 is the initial state and QF is a final state, which is denoted by a double circle. This finite automata only accept the substring 00. Then we have to draw a DFA which can read all input symbols one by one. So there is only one path in a specific input from the current state to the next state. So this is a final required DFA, in which we firstly observe Q0 which having a two input symbols, that is 0 and 1. But in this situation string can't be start with 1, so the transition of 1 is passed to the dead state, which can be represented by D. So the starting state Q0 accept 0 input but reject the input 1. So next we observe that Q1, in which also it can't accept input 1 at the second position of a string, because it can only accept 0 zeros as a substring, so it can't accept 1, and it passes towards the dead state. Okay, it passes towards the dead state. Then final state QF can be accept 0 and 1 because the condition is only for the starting substring. After the substring 0 0, QF can accept any number of zeros and ones. That's why the transition of 0 and 1 is passes to itself only. That is the self loop of 0 and 1. In next step, in next step 4, we have to implement tuple, that is the m equal to q summation del q0 and f. Q means the set of input states, that is the q0, q1, qf and e. Summation is a set of input symbols, and this language is made up of over only 0 and 1. q0 is the initial state, qf is a final state, and next one is del. Del means the transition function, which is represented in a tabular format with the help of DFA transition. In transition function is defined as the mapping between input state and input symbols. In this transition table, Q0 is initial state, so it can be represented by arrow, and the D is the final state, so it can be represented by star. In this table, according to DFA transition, Q0 having two transitions, that is 0 and 1, in which 0 is passed towards Q1 and the 1 is passed towards the dead set. So the mapping of Q0 to 0 and the Q0 1 is to the D. So according to this procedure, we can map all stages with all inputs, and then we get the transition function. Okay, I hope you all are understanding how to construct DFA. Thank you.